Welcome to Dark Sky Dive, where we explore the boundaries of human engineering and the colossal machines taking us to space. Today, we dive deep into the mind of Elon Musk and the industrial miracle happening right now at Starbase in Texas. The goal is simple, yet incredibly difficult: to build a fully reusable transportation system capable of carrying humans to Mars. Standing taller than the Statue of Liberty, Starship is the largest and most powerful flying object ever built by humanity. This facility is not just a launch site. It is a rapid production line designed to churn out rockets like cars. To understand how this is possible, we must look at the fundamental materials that make this ambitious project a reality. Unlike traditional aerospace carbon fiber, SpaceX chose stainless steel for its durability, lower cost, and high melting point properties.
This decision allowed them to work outdoors without expensive factories, speeding up the development process by a significant margin of time. The shiny exterior is not just for aesthetics. It reflects heat, serving as part of the thermal protection system during re-entry. Every weld is critical, inspected rigorously to ensure the vehicle can withstand the immense pressures of launch and the vacuum of space. The production method involves stacking these rings, a technique that allows for modular assembly and rapid iteration of design changes. Aerodynamics play a huge role, and the steel structure provides the rigidity needed to handle supersonic speeds in the atmosphere. Work here never stops, with shifts running around the clock to meet the aggressive timelines set by Elon for Mars colonization. The nose cone is a complex piece of engineering, housing the payload bay, header tanks, and the aerodynamic control flaps. These flaps are essential for the skydive maneuver, allowing the ship to control its descent through the atmosphere like a skydiver. But a rocket is nothing without its engines, and the Raptor is the most advanced rocket engine ever produced in volume. Raptor runs on liquid methane and liquid oxygen, a fuel choice specifically made because methane can be synthesized on Mars. The plumbing is a work of art, designed to manage high pressures and extreme temperatures while keeping the engine lightweight. SpaceX constantly iterates, stripping away unnecessary parts to make the engine lighter, more powerful, and easier to manufacture rapidly. The full-flow staged combustion cycle is the secret sauce, squeezing every bit of efficiency out of the propellant. It operates at insane pressures, higher than any other engine, which translates to more thrust and better lifting capacity. SpaceX aims to build one engine per day, a production rate that is unheard of in the traditional aerospace industry. For the upper stage, they use the Raptor vacuum, featuring a massive Bell nozzle to optimize performance in the void. The Superheavy booster requires 33 of these engines working in unison to lift the massive stack off the ground. This configuration provides more than twice the thrust of the Saturn V moon rocket, a true beast of engineering. Managing the heat and force from so many engines simultaneously is one of the biggest challenges the team faces. Each engine is shielded to prevent a failure in one from cascading and destroying the neighboring engines during flight. Moving the booster is a delicate operation, requiring specialized heavy transport vehicles to carry the skyscraper-sized rocket safely. The launch mount itself is a marvel, equipped with water deluge systems to suppress the acoustic shock and fire. This massive steel plate blasts water upwards to counteract the engine plume, protecting the concrete pad from vaporization. Precision is key here, as thousands of tons of fuel need to be loaded through these connections in minutes. These grid fins are essential for steering the booster back to the launch site after it separates from the ship. Unlike Falcon 9, these fins do not fold. They remain deployed to provide maximum control authority during the descent. The launch tower, nicknamed Mechazilla, is designed to catch the returning booster in mid-air using these giant arms. This catch maneuver eliminates the need for landing legs, saving weight and allowing for immediate restacking and relaunch. The engineering behind the tower is as impressive as the rocket, requiring precise movement of thousands of tons. Stacking the ship on the booster creates a vehicle nearly 120 meters tall, dominating the horizon. Once fully stacked, the system undergoes rigorous testing to ensure all connections between stages are secure and functional. The belly of the ship is covered in thousands of ceramic tiles designed to survive the scorching heat of re-entry. Each tile is unique and must be placed perfectly to prevent hot plasma from reaching the steel structure underneath. The tiles must withstand temperatures exceeding 2,000 degrees Celsius, while the ship travels at 25 times the speed of sound. SpaceX has learned from past failures, improving the attachment pins to ensure tiles stay attached during the violent vibrations. The payload volume is immense, capable of deploying massive satellites like the next generation of Starlink internet constellations. This unique deployment mechanism allows for rapid release of satellites, revolutionizing how we build infrastructure in low Earth orbit. For human missions, the interior will be pressurized and life-supported, offering a spacious environment for long-duration space travel. Developing a reliable life support system is crucial, as the journey to Mars takes several months of isolation. To reach Mars, Starship must refill its tanks in orbit, a maneuver that has never been done on this scale. This technology effectively resets the rocket equation, allowing a fully loaded ship to depart from Earth orbit towards Mars. Back on Earth, the mission control team monitors thousands of data points, ready to make split-second decisions during operations. The ignition sequence is a carefully choreographed ballet of valves opening and sparks flying to light the massive candles. As the clamps release, the vehicle rises, fighting gravity with over 7,000 tons of thrust pushing it skyward. Onboard cameras provide us with breathtaking views, showing the curvature of the Earth as the blue sky turns black. SpaceX utilizes hot staging, igniting the upper stage engines to push the booster away, maintaining continuous acceleration during ascent. The vented inner stage is a key design element, allowing the exhaust gases to escape without damaging the booster below. Immediately after separation, the booster flips and burns its engines to cancel its forward velocity and return home. Meanwhile, the ship continues to accelerate, targeting orbital velocity to begin its mission in the vacuum of space. The return of the booster is a controlled fall, guided by GPS and the aerodynamic control of the grid fins. At the last moment, the engines relight for the landing burn, bringing the supersonic vehicle to a hovering halt. A successful catch marks a paradigm shift in rocketry, proving that rapid reusability is not just a dream. Once in orbit, Starship can deploy payloads, refuel, or prepare for the next leg of its journey to deep space. The Trans-Mars injection burn is the moment of truth, sending the ship on a 6-month cruise through the solar system. Before Mars, Starship will play a crucial role in returning humans to the Moon under NASA's Artemis program. The lunar variant features landing legs and a painted exterior, optimized for the harsh environment of the lunar surface. This massive elevator is necessary because the crew cabin sits so high above the ground compared to the Apollo modules. The journey to Mars is long and perilous, requiring robust systems that can operate autonomously for months without maintenance. Protecting the human body from radiation and microgravity effects is a top priority for the mission planners at SpaceX. Power is generated by efficient solar arrays, ensuring the life support and navigation systems remain operational throughout the cruise. As the red planet looms larger in the window, the crew prepares for the most dangerous part of the mission. Entering the Martian atmosphere is tricky. It is thick enough to burn you up, but thin enough to provide little lift. The landing burn on Mars must be precise, settling the massive ship gently onto the uneven and dusty terrain. Safe arrival marks the beginning of a new chapter for humanity, the first permanent footsteps on another planet. Before humans can settle, autonomous machines will likely build the initial power plants and fuel production facilities. Using the Sabatier reaction, they will harvest carbon dioxide from the air and ice from the ground to make fuel. The long-term vision is to build a self-sustaining city, ensuring the survival of consciousness if Earth faces a catastrophe. Reusability applies here too. The ships are designed to return to Earth, creating an interplanetary transport network. But let's return to the present, where the hard work of testing and iterating is happening every single day. Cryogenic proof tests push the tanks to their limit, simulating the thermal shock and pressure of flight loads. Explosions are not failures in this development model. They are valuable data points that highlight weak spots in the design. The team quickly learns, fixes the issue, and rolls out the next prototype, often within weeks of an incident. The rocket garden serves as a visual history of the program, showing how the design has matured over the years. We have seen landing legs disappear entirely, shifting the complexity from the expendable rocket to the reusable ground infrastructure. Mass manufacturing is the key to lowering costs, making space travel accessible to more than just governments and billionaires. Inside the beast, miles of wiring connect the flight computer to sensors, valves, and actuators throughout the vehicle. SpaceX uses redundant flight computers running custom software to manage the unstable flight characteristics of the vehicle. Telemetry is beamed down via Starlink, ensuring that even if the rocket is lost, the data is saved. The ultimate goal is to reduce the cost to orbit by a factor of 100 or even more. While the shuttle cost over $1 billion per flight, Starship aims for a cost lower than a Falcon 9 launch. This technology could also revolutionize travel on Earth, enabling trips anywhere on the globe in under an hour. Offshore launch platforms will likely be used to mitigate noise issues for these frequent Earth-to-Earth hypersonic flights. Converting oil rigs into spaceports was an early idea, showing the innovative approach to solving logistical launch constraints. Precision manufacturing allows for tighter tolerances, which improves the structural efficiency and safety margins of the final vehicle. Cryogenic testing ensures the steel does not become brittle in the freezing darkness of deep space. The control surfaces require immense torque to move against the supersonic airstream, powered by high-performance electric motors. Technology transfer between Tesla and SpaceX is evident, with battery and motor technology finding its way into rockets. The interface for the crew will be modern and intuitive, relying on touchscreens rather than thousands of physical switches. Training for these missions is rigorous, preparing the crew for every conceivable anomaly that could occur during flight. NASA's support validates the design, providing funding and expertise to help certify the vehicle for human spaceflight. A night launch is a spectacular display of raw power, visible for hundreds of miles across the coast. These events draw thousands of spectators, inspiring a new generation of dreamers to look up at the stars. Just as Apollo inspired the boomers, Starship is igniting the imagination of the Artemis generation today. As orbit becomes busier, Starship will serve as the heavy hauler, maintaining and expanding our orbital infrastructure. Astronomers dream of the telescopes that can fit inside Starship, allowing us to see further back in time. We could see vast commercial space stations, hotels, and laboratories built using the massive volume of spent starships. Back on Earth, the sun sets on another day of frantic progress at the gateway to Mars. The pace is relentless because the window of opportunity for becoming multi-planetary might not stay open forever. Musk often speaks of the Great Filter, the idea that we must expand beyond Earth to ensure survival. Looking back at Earth, we realize how precious and fragile our cradle is, and why we must protect it. While Mars is the first step, the technology developed here could eventually take us to other star systems. The real power of SpaceX lies in its people, the brilliant minds dedicating their lives to this mission.
From software to metallurgy, every discipline is pushed to its absolute limit to achieve the impossible. Testing is brutal and unforgiving, ensuring that only the most robust hardware makes it to the launch pad. Logistics is a massive challenge, requiring a constant stream of fuel and supplies to keep the operation running. By chilling the fuel to near freezing points, they can pack more mass into the tanks, increasing range. The rocket appears to breathe as it vents boil-off gases, waiting patiently for the countdown to reach 0. The final 10 seconds of the count are the longest, where years of work come down to a single moment. When it flies, it carries the hopes and dreams of all humanity, striving to break our earthly bonds. Passing through maximum dynamic pressure is the point of highest mechanical stress on the vehicle's structure. Soon, we will see this vehicle landing on the moon, returning humans to the lunar surface after 50 years.
This return will be sustainable, establishing a permanent base for science and exploration on our nearest neighbor. Taking off from the moon is easier due to lower gravity, allowing the ship to return without a booster. Returning from the moon or Mars involves hitting the atmosphere at incredibly high speeds, testing the heat shield. The energy dissipated during re-entry is enormous, turning the kinetic energy of the ship into blazing heat. Mastering the catch of the ship itself is the final piece of the puzzle for full and rapid reusability. Post-flight inspections will eventually become as routine as checking an airplane after it lands at an airport. The vision involves turning the ship around in hours, not months, achieving airline-like operations for space travel. As flight frequency increases, the cost will drop, eventually making a trip to Mars comparable to buying a house. Space will no longer be the domain of a select few. It will be open to adventurers from all backgrounds. Musk envisions a fleet of 1,000 ships departing every synodic period, transporting 1 million people to Mars. Over generations, we might even terraform Mars, turning the red dust into a green and blue living world. It is a long-term project, but one that ensures the light of consciousness will not be extinguished easily. Future generations born on Mars will look back at Earth as their ancestral home, a bright star in their sky. But today, it starts with welding steel, testing engines, and learning from every single flight and failure. It starts with the dedication of thousands of people who believe in a future that is bigger than themselves. Starship is more than a rocket. It is a symbol of human ambition and our unyielding desire to explore. Thank you for watching Dark Sky Dive. Subscribe for more deep dives into the technology that is shaping our future.